Have you ever wondered what makes the concrete strong? Or better yet, what's the strongest mix in the world? Hi everyone, I'm your lab engineer Lawrence, and today we're going to uncover the science behind the concrete strength made simple and fun. Don't worry, no lab tests, no boring graphs, just real talk, simple science, and maybe just a few jokes along the way. By the end of this video, you will understand how concrete gains strength, why some mixes perform better than the others, and which one truly takes the crown as the world's strongest. Alright guys, let's start with the basics. Concrete is composed of cement, water, fine aggregates like sand, coarse aggregates like gravel or crushed stone, and sometimes admixtures. It's like a team project. Cement is the leader. It binds everyone together. Water is the motivator. It activates the reaction. Then sand and gravel. These are team members who do all the heavy lifting. So when cement and water meet, something magical happens. This is called hydration. It is basically a chemical reaction where the cement starts hardening, creating the strong matrix that holds everything together, including sand and gravel. And admixtures, those are the specialists who show up with fancy skills like faster setting, waterproofing, or higher strength. Concrete mix proportions are usually expressed as a ratio, like 1:2:4 or 1:1.5:3, representing cement, sand, and coarse aggregates by volume. A 1:4 mix is good for several purposes. But as we shift toward 1:1.5, and 3, the strength increases because there's more cement and less aggregate. Let's say you're building a simple house floor. You might use more gravel for cost efficiency to save more money. But if you're building a bridge deck, you better bring out the good stuff. Strong, well-graded aggregates and high-grade cement. Oh, and a fun fact, concrete hates tension. That's why we add steel reinforcement. It's like giving concrete an invisible exoskeleton. Without it, your beam might bend like a banana under stress. When we talk about concrete strength, we usually referring to compressive strength. It is ability to resist crushing when a load is applied. Imagine a cylinder of concrete being squeezed from both sides. The higher the load it can take before cracking, the stronger it is. So what actually makes concrete strong? Let's break it down. Cement type and content. Using more cement or a high early strength cement like type 3 cement can increase strength, but also need to consider the cost and shrinkage. But too much of it and you'll get cracks faster than your phone screen. So balance is the key. Water to cement ratio. The golden rule: less water, more strength. And the ideal range, around 0.25 to 0.35. But if you add a lot of water, congratulations, you just made a concrete soup. Aggregate quality. The better your sand and gravel, the better your concrete. Avoid dusty or weak stones. Using beach sand full of salt, that's how you create cracks before the project even starts. Admixtures. These are the superpowers of concrete. As the strength increases, workability decreases. The mix becomes stiff and hard to place. This is where superplasticizers come in. These are the chemical admixtures that make concrete flow easily without adding more water. In high-strength concrete, superplasticizers are essential to maintain both strength and workability. Curing conditions. Concrete doesn't dry, it cures. It needs moisture and time. Temperature control and moisture management play big roles here. If it's too hot, the water can evaporate too quickly. weakening the concrete. If it's too cold, the mix might not set correctly. Engineers often cover slabs with wet burlap or use curing compounds to prevent early dyeing. There's C20, C30, or C40. The letter C stands for compressive strength, and the number means the strength in megapascals or MPa after 28 days of curing. So C20 is perfect for residential floors and pavements, while C30 is stronger and great for commercial projects, while C40 is the heavy-duty champion. It is one of the strongest standard concrete mixes used in real-world construction. This type of concrete is used for heavy-duty structural elements like beams, columns, and foundations, where strength and durability are essential. But then, the engineer said, "We can go higher." Did you know that Burj Khalifa used C50, C60, and even C80 grade concretes? Self-consolidating concrete for the foundation, high-performance mixes for the upper levels, all carefully designed to withstand the brutal Dubai heat and massive loads. Alright, time for the superstar, the ultra-high performance concrete or UHPC. We're talking about 120 megapascal and sometimes even 200 megapascals. It was first developed in France in the 1990s and is still the gold standard for toughness. That's like stacking 10 elephants on 1 square inch. And the concrete saying, "Is that all you got?" So what makes UHPC special? It's perfect particle packing, every space filled. Very low water content. Silica fume and superplasticizers for maximum density. Steel or synthetic fibers to resist cracks. It is used in bridges, skyscrapers, blast-resistant walls, and futuristic architecture. For example, the Milo Viaduct in France and Expo 2020's Al Majlis Pavilion in Dubai both use UHPC for strength and beauty. And the downside? It's pricey and complex. So, UHPC is like the Lamborghini of concrete. You don't use it for your driveway, unless you really want to flex on your neighbors. After all that, let's answer the big question. What is the strongest mix in the world? And the title goes to Ultra High Performance Concrete or UHPC. It combines fine powders, minimal water, and advanced admixtures to achieve unbelievable strength and durability. But remember, stronger is not always better. A smart engineer doesn't just design for maximum strength, but for the right balance of strength, cost, and purpose. So next time you pass a bridge or a skyscraper, remember, that structure is not just built. It is engineered with knowledge and care. And if you enjoyed this video, don't forget to like, share, and subscribe for more fun engineering insights. So this is your lab engineer Lawrence reminding you, great structures begin with great knowledge. Thank you for watching. See you on my next video.